Okay, so we're dealing with application problem, and we have this individual who's shooting basketball, and basketball, if you think about its trajectory through the air, it's parabolic in shape, so we can model it using a parabola or a quadratic function, where t represents time in seconds after the ball is released, and h of t is the height after t seconds. So a couple things here, a little bit of math like lingo, if you will, but h of t is height as a function of time. So what that means is height's dependent upon time based on this model, and that's how we would say it. So we want to know how long it will take to reach its maximum height. What is the maximum height? And we want to round our answer to the nearest hundredth if that's necessary. Okay, so real quick, we know enough about parabolas that we know that because this guy is negative right here, it's going to open down. So before I do any math, I'm going to go ahead and draw a generic picture. I'm going to go ahead and shrink this a little bit, put a little bit of a graph on the other side here. I don't know exactly where it's going to cross the x-axis. I do know that the y-intercept is 5, so I might have some graph that looks like this. Just because the intercept is 5 doesn't mean that that's the highest point. So I want to make sure that even though I don't know that, want to possibly account for that in my picture. Well, this would be the highest point, right? So our y value for this is going to be our height, and our x value for this is going to be the time that it takes to reach that point. This guy is the vertex of the parabola. And so how do we find the vertex of a parabola algebraically? Well, we have the formula where x is equal to negative b over 2a. This is the axis of symmetry. It is also the x in the vertex. Okay? So this is going to represent our time. So let's do that first. We have a negative 24 all over 2 times negative 16. And that's going to give us negative 24 over a negative 32. That's equal to 3/4 or 0.75 seconds. So it's going to take 0.75 seconds to reach its highest peak. Okay? So we found that. Now we want to know what the actual height is. So in order to find the height of the ball, well, we have an equation. We have an equation which is h of t is equal to, I'm going to draw a little line here, negative 16t squared plus 24t plus 5. Well, if time is 3/4 or 0.75, well, what's our height as a function of time? Well, 3/4 is the max, is the time at which the ball is at its highest peak. So I'm going to go ahead and plug in 3/4, and I'm going to go ahead and calculate this. So h of 3/4 is going to equal, so I'm just going to do this without a calculator. 3 squared is 9, 4 squared is 16, plus 24 divided by 4 is 6, so 6 times 3 plus 5. We're running out of room here, so let me move this up real quick. 16s cancel out, so I'm left with negative 9. 6 times 3 is 18 plus 5. That's going to give me a 9, so 13 feet. So if we look at it as just a vertex, so if we're talking about no application, the vertex of this parabola is 3/4 13. But now that we're dealing with some sort of application, we say that time is equal to 3/4, height is equal to 13 feet. And this is our max height because it's at the maximum, and this is how long it takes to get there. Okay, and that answers both those questions that were asked in the problem. So all we're finding is the vertex of the parabola, the x value is our independent variable, and the y variable is our dependent. So time is a function, height is a function of time.